Okay, hi everyone. You've made it to the last lesson of this semester. Thanks for bearing with me and watching my videos and doing the hard work that you've done this semester. So, this is what we're going to do for our last lesson. We're going to review the linear relations unit. Okay, so what that will cover. So today you've got Monday, Tuesday to do your last lesson, which is basically a review. And then on Wednesday will be a quiz. This will be the last quiz, and that will be it for the course. Okay, so what the quiz will cover and what I'll kind of go over today is partial and direct variation, writing equations from word problems, graphs, charts. Okay, those are the three that we covered in terms of writing equation. Lastly, for those that have not completed everything in terms of submitting work, like emailing me your completed worksheets or finished all of the quizzes on Edsby, please do so by the 19th. This is the last day that I can accept work because my report card marks are due on Monday. So I'll be working on those over the weekend. So Friday is the very last day that you can submit a quiz or your work, okay? Okay, so let's start on the review. Okay, rate of change is something that we did in our last unit, but I want to go over two examples today because it is necessary for writing the equation of a graph, and it's often a concept that takes a little bit extra practice. Okay, so rate of change, or ROC, in our equations. Okay, so I'm just going to give you 2 points. You know the first step is to pick 2 points on the line. Okay, so let's say those 2 points are 2, 6, so that's a point, and 5, 8. Now, being that this is review, you should be able to pause right now, take those 2 points, and come up with your rate of change. Okay, I'm going to do 2 examples, so if you need a quick review, watch this one, but make sure you pause for the next one and give it a try on your own, okay? So the next step that I recommend is stack points. Okay, so let's stack them. So 5, 8 is a point, 2, 6 is a point. Okay, when you subtract, recall that every point has an x-coordinate and a y-coordinate, and the x-coordinate is always written first. Okay, the rise is the difference in the y-coordinates. Okay, and the run is the difference in the x-coordinates. So I'm going to write this here just to remind myself. Difference in the y-coordinates, that's rise. Difference in the x-coordinates, that's run. Okay, it makes a difference, of course, because when you divide them, you've got to know which one goes on top. So my rise is going to be 8 minus 2. So rise equals 8 minus 6, which equals 2. So my rise is 2. My run is 5 minus 2, okay, which is 3. So that's kind of steps 3 and 4, figuring out your rise and your run. Okay, step 5 is actually calculating your rate of change, which is equal to rise divided by run. So in our example, our rise is 2 and our run is 3. Okay, so you could leave it as a fraction because that is in the lowest terms, that fraction, or you could change it to 0.6. It goes to 666, repeating, so 0.67. Okay, either one would be just fine. Okay, so that is the example that I was going to go over, and I'll give you one more so that you can make sure you try it on your own, okay? Okay, so the 2 points are 0, 5, and 2, 1. so there's your 2 points. Pause. Now the solution. Okay, so that's step number 1 where we pick our 2 points. Step number 2, we'll stack them. So 2, 1, 0, 5. Okay. Step number 3 is to figure out our rise, which of course is the difference in the y coordinates. And then the next one, we'll be figuring out our run, which is the difference in the x coordinates. Okay, x, y. So our rise is going to be 1 minus 5. 1 minus 5. I'm subtracting a bigger number, so I know I'm moving into negative, so that's going to be negative 4. Run, difference in the x coordinates, 2 minus 0. Okay, so that's positive 2. Sign really makes a difference, okay? So make sure you're careful about getting the correct sign. And then my rate of change is equal to the rise divided by the run. My rise is negative 4. My run is 2. So negative 4 divided by 2, it's going to be a negative, and 4 divided by 2 is 2. So my rate of change is negative 2. Okay? Okay, next. What I'm going to do is I'm going to do one example from each in terms of writing equations. Okay, so I'll give you an example from using word problems, graphs, charts. Those are the 3 that you need to be able to write examples for. A linear equation. Okay, so I'll put up at the top the big formula that we use for all of them. So dependent variable equals the rate of change times the independent variable plus the starting point. Okay, and this is not a formula that you need to memorize, just one that you need to be able to know how to use. Okay, so my first one, yeah, we'll do this one first. So this one is a graph, so I'll try to draw this graph as best as I can on here. So this is the height of a balloon in meters, okay, and that's going up by tens. So 0, 10, 20, 70, yeah, that's high enough. And then the bottom will probably be time in seconds. And here we're going up by 5s. So 0, 10, 20, 25, 30. Okay, so it is going to start at 60 meters and fall at a constant rate. Okay, so constant rate, that's why my line is straight. And it's going to take 30 seconds, at what point it's going to be hitting the ground. Okay, so just to understand what's going on when the graph looks like that. So first thing we need to do is figure out all of these components of our equation. So the starting point, the rate of change, the dependent variable, and the independent variable. Okay, so I always figure those 4 out before I start plugging things into the equation. So my starting point, where am I starting? Here on a graph, this is where I'm starting, right? When the independent variable is at 0, where do I start? Here I'm starting at 60. So that is my starting point. My rate of change. This is why we went over rate of change just before, because here we need to calculate the rate of change for this line. It's not given to us. Okay, I'm going to pick 2 easy points. So the point 0, 60, that's this one. Right, 0 and 60, and this point is 30, 0. So there's 2 points. So let's calculate our rate of change. So 0, 60, 30, 30, 0. Okay. This will be our rise, and this will be our run. So my rise is going to be 60 minus 0. So my rise is 60, and my run, always going the same direction, 0 minus 30, so negative 30. Okay, so then to calculate my rate of change, it's rise divided by run, which is going to be 60 divided by negative 30, so negative 2. Okay, so my rate of change is negative 2. So that means that it's falling at negative 2 meters per second. Okay, just as a side note. So my dependent variable, this is always my dependent variable axis. Recall we kind of talked about this, right? If you drew this, you can draw a D here, so then you know this is your dependent variable, and you can draw an I here, so you know that's your independent variable, okay? So my dependent variable is going to be the height of the balloon, so I'm just going to use an H. Just try to use one letter, okay, for your variables, and then my independent variable is time, so I'll just use T. Once I have all four things, it's just a matter of putting them in the right order to come up with your equation. So I'll do that right here. So my dependent variable, that's H, equals my rate of change, that's negative 2, times my independent variable, so negative 2t. If you put brackets there, that's fine. If you don't, that's fine too, because you know that when they're side by side, it's being multiplied. Okay, and then plus my starting point, which is 60. So that would be the equation of that line. Okay, and equations can be useful because you could say, okay, at time t equals 10 seconds, you put 10 in for this, and you could calculate what the height is of the balloon, okay? Okay, so that's your example with graphs. I'll go over now an example with a chart. Okay, so this is for Kohl's earnings. So here we go. We've got hours, and earnings. And this is going up by 2, so 0, 2, 4, 6, 8, and 0, 12, 24, 36, 48. Okay, this is in dollars, and this is in, that's hours, obviously. Okay, so this is all the information we're given, and we have to come up with an equation, okay? So I'll do what I did before. Well, I write down, okay, what's my starting point, what's my rate of change, what's my independent variable, and what's my dependent variable. Well, my starting point at time 0 hours, I've made $0. Okay, so my starting point 0. My rate of change, you can do this one of two ways. You can take the difference here, okay, and so what is this going up by? 12 minus 0, 24 minus 12. This is going up by 12 every time, okay? So it's going up by 12. And then you divide it by, this is going up by 2. You divide it by what your independent variable is going up by. Okay, so my rate of change would be equal to 12 divided by 2, which is 6. Okay, so that's one way. Figure out your first differences or your what's it going up by for my dependent variable and divide it by what it's going up by for my independent variable. That's one way to do it. The other way is you can look at, if I was to graph this, each one of these, right, would be a point. So there's a point, there's a point. So you could just pick 2 points and calculate your rate of change like you would do for a graph. Okay, so I won't go over that because we've done it a few times, but just know that there's 2 different ways that you can do that. Your independent variable, this is your independent variable. Whenever you have anything having to do with time, whether it's months or years or minutes, hours, whatever it is, that's going to be your independent variable. So I'm going to use H for hours, and earnings, I'm going to use E. Okay, now I have all the information, and I can put it together to come up with my equation. So dependent variable is first, so that's E equals my rate of change, which is 6, times my independent variable, which is H, plus 0, so I can just leave that out. Okay, that's it. Okay, next one, last one. I keep thinking I need to give you guys time to write that down, but of course you can just pause it in the video. Okay, so the next question says, Zach and Sebastian ran a marathon. Okay, so I'll just write down the distance. So they ran a distance of, maybe you already know, but a marathon is 42 kilometers. Okay, it took them, so time, it took them 4.5 hours. And they ran at a constant speed for the entire race, and you're asked to come up with an equation. Okay, so just to read the question again, Zach and Sebastian ran a marathon, a distance of 42 kilometers. It took them 4.5 hours to run the race. They ran at a constant speed, so you know the rate of change doesn't change, it's constant. Write an equation. Okay, so we will write down the components we need to figure out. So our starting point, our rate of change, our independent variable, and our dependent variable. Our starting point, well, when you start a race, you're going to be at distance 0, right? So my starting point is going to be 0. My rate of change, well, I'm not given the rate of change, not given their speed, right? But I can calculate their speed because I know their total distance. I know how long it takes them to cover that distance. So then I can calculate their speed in terms of kilometers per hour. So 42, this is going to be rate of change. 42 divided by 4.5 is going to give you your rate of change. And I'm not sure, I want to get that wrong. So 42 divided by 4.5. So it's 9.3 and 3 repeating. So I'm just going to write 9.3. And it's kilometers an hour. Okay, so here I'll write 9.3 for the rate of change. My independent variable, my dependent variable. I know one's going to be distance, one's going to be time. Well, you know, if you're ever given time, that's going to be your independent variable. Okay, so I'm going to write t for that, and my dependent variable then is my distance. So to write an equation for the two boys running this race, the dependent variable, so d, equals the rate of change, 9.3, times my independent variable, which is t, plus my starting point, which is 0. So that's it, okay? So you could say, okay, after an hour and a half, I'm just going to do this for fun. After an hour and a half, so t equals 1.5 hours, how far have they ran? You'd say, okay, distance equals 9.3 times an hour and a half, 1.5. And you could figure out how far they've run. So what is 9.3 times 1.5? It's about 14. So then they have run 14 kilometers. Okay? Okay, so that is it for your last lesson. Congratulations on making it this far. I'm sorry I don't get to see you in person to say have a great summer, but I hope you all have a great summer. And I hope to see you in September. Okay, bye-bye.